think about what interests you about it. Is it the process technology? Is it the materials? I'm a materials engineer, so the materials piece was always really interesting to me. Designers tend to be very interested in additive because this ability to design new shapes is really exciting, that you would have a hard time getting to in a conventional or legacy manufacturing sense. And then if you're fortunate enough that you have the ability to go and get like a certificate in something, or kind of get that more formalized training or education in it, that's a decision people could make. But if you're like, that's a great symbol for a young person to show your potential employer that you're really interested, because you went off and showed some initiative and got some education.
Greg Sheldon here, your host of Metal, Steel, Manufacturing, and Business Pro podcast, where you learn everything about the metals and manufacturing industry that make your modern day life possible.
Hello, everybody. Welcome to the show. Today we have John Barnes. And John has 30 plus years of experience in aerospace and product development. He's worked for Honeywell and Lockheed Martin Skunk Works, the Commonwealth Scientific and Industrial Research Organization, and Arconic. He has been involved in additive manufacturing since the 1990s. He has worked in development and implementation. He established the Additive Manufacturing Research Group and the CSIRO, which is one of the acronym I just said above, and holds 15 plus patents and applications in additive manufacturing. He has received numerous awards as an active member and leader in the industry, and he has a Bachelor of Science in Materials Engineering from Purdue University. What a pleasure to have you, John. Thank you for coming.
Yeah. Thanks, Greg.
You're welcome. So tell me all about the additive manufacturing industry. How'd you get started?
My usual sort of anecdote here was I was the least valuable engineer at Honeywell. And so they put me on this project. They put me on the project that was clearly going nowhere. And that was an additive manufacturing technology. It was actually a pretty cool program. It was a CRADA that was put together by Sandia National Labs with 10 companies who were there to support. In that case, it was actually 2 scientists who were leaving the lab that had an idea for a company, and they had something called the entrepreneurial leave of absence. So they put this Sandia together, and it was this really eclectic group. It was Honeywell, Lockheed Martin, Ford, Hasbro, 3M. It was very different. And it was really, I was very fortunate to have been selected to be on it. And that was, 97, 98, something like that. And so it was a very early form of metal additive manufacturing.
Yeah. So what's changed since then?
Well, people write a lot more articles about it now than they used to. There's a couple conferences about it. No, it has progressed significantly. It has expanded significantly. It's much more diverse as a process technology. So we always tell people, at my firm now at TBGA, that there's, they come in usually with a question on additive, and they think it's like powder bed or it's directed energy deposition. But we kind of back up and say, well, there's kind of 7 different families of process technologies. Within that, there could be a subgroup. And so there's that. The materials piece has grown significantly. The what we call the digital side, so the ability to kind of work that digital workflow, how you get from CAD, your intentional part that you want, translating it through the slicer to think of toolpath planning. All that stuff has gotten much easier and much better, still not perfect. And then of course that has to be done for each of the family process technologies, because it's different for powder bed than it would be for binder jetting, for example. And then, the other side of it is the people side. And I'd say we're still relatively early in those days. The awareness of what additive manufacturing is still prone to my hyperbole maybe than facts. And so it's one of the things that we do. We try to work with companies to get them to appreciate what it is and what it isn't. So we often say we don't care that you use it, but if you don't use it, make sure it's for the right reasons, because in a year or two, those reasons could, they may have been improved. So, understanding process economics, all that stuff. So, I think the whole situation has improved. It's still overall a very small percentage of global manufacturing, but, it is growing at 20+% a year by every estimate that I've seen.
Okay. So why would somebody, because when I think of additive manufacturing, I immediately think 3D printing. Okay. And I think of the desktop units like desktop metal or something. Is that typically what we're talking about here? And because you said a few processes there that I have no idea what they are. And I'm just wondering what is used the most in the industry? Is it 3D printing, and why would I choose that?
Well, there's a couple of different use cases out there broadly. So if you just look at the material system, so you've got plastics and the metals. Plastics has been around longer, as a 3D printing technology. So it's got a good 10-year head start on metals. Metals hasn't been around as long. It's a little bit less mature. And typically you see, we've broken it up into, what we call the maturity model approach. And so at that first level, people are making prototypes. So plastic, metals, doesn't matter. Maybe you're just looking to make a shape. You need to get something into a test. What you're printing may have nothing to do with the test, other than you need it to be there to conduct the test on the thing that you're actually trying to measure. The next area is what we call the indirect benefit, which is you're doing it to make a tool. Maybe it's a shop aid, maybe it's like a cast tool. So you're going to cast into the 3D printed piece, or you've used 3D printing to make the that cast shape. Also, a lot of uses for assembly, where you're making temporary tools to help assemble something. So in other words, these are all cases where the final product doesn't have any 3D printing in it.
Well, okay. Yeah.
It's assisted by 3D printing. And that just helps you with the usual stuff like consistency and making it easy on people to do their job. Tools are always helpful for that. Then at the next level, you're stepping up into what we call that part for part replacement. You've seen this mostly. People say, "Hey, look, today I make this thing. Can I 3D print it?" And usually the answer is yes, you can, but you probably shouldn't. A similar case to that might be that you might need a spare part. In which case the cost element doesn't matter so much, because if you can't get this part in their way, then it's more about schedule than it is about cost sometimes. And those spare parts pieces, this is a problem we see, typically with militaries, because they have a lot of, aged platforms where, the platform itself is out of production. Well, look at a B-52. I mean, we haven't made those in 50 years. So, the spare parts and how you get to those spare parts, could be done through a printing technique.
Okay.
And broadly, so then you kind of go from there, which is you're looking at combination of parts, and then you get to the one that everybody likes to look at. It's this, wicked bionic-looking thing, and it can only be made by additive. But we kind of like to tell people, like, that's a good aspirational goal. It's similar to buying a pair of running shoes and then training for a marathon. You don't just go run the marathon. You kind of step up into that process, because you have to match the requirements with skills and knowledge, in your workforce to get you there. Rome wasn't invented in a day, or built in a day. So that's the usual approach that we talk about.
Yeah.
And then you kind of touched on 3D printing versus additive manufacturing. So
Yeah.
we view 3D printing as the the actual printing piece of it.
Okay.
Additive manufacturing covers everything from the material that I'm feeding into it. I'm going to print the part. I might do a thermal treatment to it. I might machine it. I might do an inspection to it. That's that whole supply chain of value add that has to happen.
Okay. Okay. All right. So I think 3D printing's really cool, and I agree with you. You go to these trade shows and it's awesome and stuff, but I mean, it doesn't really seem like there's much application for it in mainstream business. But what I do see application for is additive and subtractive.
Hmm.
And, is it almost as if it's an educational process, like you said, where you need to get people to hear and their mindset, and then we can go backwards a little bit in additive and subtractive? Is that kind of where it goes with people?
Yeah. Yeah. You'll see that a lot, which is there's this kind of jump to, oh, everybody's going to have a 3D printer and everybody's going to make their own parts and we'll never have to go to Home Depot or, ever again. I don't think Home Depot is concerned about that, nor do I think they should be. Because some of these things are, most products are engineered. They're not just widgets that it's not like you're making staples, for a stapler. They're usually very integrated. There's heat treatment matters, or, they've got details that matter, which you need to get through with machining. So we talk about this broadly as designing for additive manufacturing. And it's just like everything else. There's a design for manufacturing. There's design for assembly. Design for manufacturing with an additive angle to it is a little bit different than what most engineers like myself would have been used to, because if most of manufacturing is about subtracting, we start with a block, we start with a big piece of wood, we carve it out. Additive is really about adding material where we need it. So it's almost the inverse. So there is a bit of unthinking that's involved. However, to your point, when you need critical dimensions and critical tolerances, you're probably going to use the tools that are really good for that. CNC machining. So what we teach people is this holistic process that says, if I'm going to get to sort of a near net shape with additive manufacturing, I'm then going to use a CNC device to get me to the final shape.
Right.
And then, if that's true, then we have to allow you some material to take off, which means we're going to print a little bit of a larger shape. But again, it's just like casting. It's just like forging. You print the part that you need is buried in that casting or buried in that forging. And then it's a question of how much machining do I need to do to extract it back out. There are people that, on the plastic side, it's much more commonplace to go mostly direct. So if you look at like the Invisalign braces and things like that, those are all 3D printed and they're kind of ready to go. I'm sure I'm oversimplifying it, but it's a little bit material dependent, and then of course, what are you doing with it? It's one thing if you're making an airplane part. It's a very different thing when you're making, a shifter knob for a Volkswagen.
Yeah, absolutely. So how far, we're going to go into the world of hypotheticals here. How far off are we for having every business having a 3D printer in their shop, like so that you can do these things? Because beyond prototyping, I mean, production type things, is that crazy at this point, or is it starting to make sense?
It's not as crazy as it used to be. I mean, I still see that there's a productivity issue with additive. And so where it tends to solve at that closer to the bespoke, closer to the small production run, closer to, maybe more customized pieces. It's why aerospace and defense is interested in it, because they don't need 1 million parts a year. They need hundreds to 1,000 parts a year. But you can get to these very lightweight parts because of the design component. And then, I'd say that's where the adoption piece slows down, because it is so design intensive. If you're going to get value out of it, your designer has to know how to design for it. Otherwise, it's the usual problem of, well, I don't know how the process works. So, what do I do? So I think we're probably still years away from, every machine shop having a 3D printer. But I would tell you this year, there's more machine shops with 3D printers than there were last year.
Okay, good to know. And then the education piece, where does somebody, I mean, they're integrating that into schooling, I assume. Yes.
Yep.
And into engineering. Okay, that's good.
Some schools are stronger in it than others, but there's places where you can get an entire master's degree now in additive manufacturing.
Oh wow. Oh, okay. That's really cool. And then when it comes to AI design, because I kind of lump them in my head together, where you've got, because again, traditional processes can't exactly make something that's designed in an organic way like AI seems to do. What are some ways, because I use SolidWorks, but I can't find the AI add-on to it. What programs can we use to start designing with artificial intelligence?
So I think there's a couple. AI is a way to get there. I would say you're broadly describing an area we call generative design, and so it doesn't. It's just physics. It's like everything else, but it's different in that you put your boundary conditions in, maybe your interface points, your loads, and then that simulation tool tells you what material you need to react those loads. And so typically that's where you get these very kind of cool nature looking structures. It's not actually, doesn't have anything to do with additive. It just may be that because additive is inherently more flexible, that it's easier to do it that way.
Okay.
The added piece then with AI and machine learning is that ability to kind of learn from, iterations. And so there's a very interesting guy named Ryan McClellan at NASA, and he has a whole thing he calls evolved structures. And he uses AI in this manner to kind of move through what I call the trade space. So inevitably when you're designing a new part for something, you have a blank sheet in front of you. So what's the most efficient structure? Well, it does depend on a lot of other things sitting around it. And so you'll design a part and then you'll come together, and the engineer who's designed all the parts that sit next to you, and then you have to go through another optimization path to make sure that they fit together well. AI is really good at that optimization piece and what I call moving through the trade space. So it continually does these step changes as it says, oh, if I do this, I can take this mass out, I can take that mass out, and it starts to look like this. Okay, at some point, you can't know all of the boundary conditions at day one. You may come back later and say, well, it turns out that I'm going to be in the vacuum of space, so that's going to put a new requirement on, or the temperature is going to be this now instead of that. So that helps you. It does the physics for you, and it kind of tells you what this thing really sort of wants to look like. And that kind of tells you what a very efficient structure wants to look like. But a human typically still has to come in because it's a very complicated problem, specifically for spacecraft, aircraft, even automobiles. So you have to think about, well, we're sitting in a vibration situation. We're sitting in a temperature situation. It's a human's interfacing with it, all these different things that could be. So it usually takes a human to come in afterwards and say, is this really going to work? Is this going to be successful in the application? And kind of the most easy example I can give to that is that sometimes you don't really need to have a solid outer mold to it, so like a skin. Let's say the whole thing wanted to be kind of open and latticey. But let's say the application is underneath a car. If that's your situation, you're going to be trapping a lot of dirt and dust and accumulating things. So very often then having a closeout or having a solid outer skin is important. Well, you can still do that, but again, the computer's not going to know that that's the situation. So you need to tell it that I need this skin on it. That's going to keep it kind of clean. So those are just kind of tips and tricks. But if you ever get to see Ryan, I think he was written up recently in one of the magazines, but he's got his whole thing of evolved structures, which is
Well,
pretty interesting to look for.
I will definitely look that up. Evolved structures. Very cool. Thank you for that. So what kind of challenges are happening in the industry? I mean, I asked you what the history, but I mean, right now, is it the education thing? Is that the biggest?
Yeah, it is, because it's the first biggest obstacle that anybody's going to run into, and especially when you think about going into these, it's one thing if you're at a small to medium enterprise. Once you get to medium large, okay, well, there's the engineers, maybe they get it, but their manager doesn't get it, or
Right.
the levels of management, and then where does it fit into all the other priorities that you have to go at and think about. So that's where we try to come in with a set of our tools to help people sort through where does this fit. And if you're an engineering company and a product design company, one of the things that Additive does for you is to help you kind of think about your design cycle a little bit differently. Because let's say 10 years ago, we got to the point where we were very reliant on computing, doing simulation analyses, and we let that do the bulk of the work. And the problem was then that took a lot of time. So that pushed the schedule. Now we're kind of a point where with 3D printing, we could make a shape, test it, make it, test it, make it, break it, make it, break it. Sometimes that's a better answer because the analysis is very complex. So not always, but sometimes. And so it's another tool for, I would say, that the manager of that design organization needs to understand, when am I going to deploy a 3D printed approach to help me get through this, or when am I not? And then it should just be another tool that I have to play with.
Yeah, it's hard for me to envision it in sitting here talking to you, but what would be the point where somebody would say to themselves, "Oh, maybe we should use 3D printing"? Like, is there like something that happens?
Yeah, there's a couple of good examples. One is, it's with SpaceX. It was with any number of companies. So inevitably what happens is you get to the point where you've got a test, or these rocket tests are very expensive, and if you push them off, you're keeping an army of engineers every day. You're paying them to be there. So getting the test is really important. And so inevitably the story they like to tell is there was a casting that they couldn't get, and so they went ahead and printed the part. Let's say that part wasn't essential to the operation of the test, but there's no unimportant parts in a rocket engine. So
yeah,
it has to be there, but it's only going to last for a finite period of time. It's not taking anybody into space. It's a very controlled environment. So that is a very good example where that you can't get the part that you ordered. You use Additive to come in and print a replacement, and then they never went back. They just said, "This is the way.
Okay,
We're committing to doing this." Now, most of the lift companies in the rocket space are completely reliant on Additive to do what they need to do.
Okay.
The other instances are things like, I'll say, you can get to a lighter weight part because you can consolidate many different parts into one. So this is not a new idea. It's called unitization, or combining multiple parts into one. Well, when you do that, you've taken out a lot of different manual steps. Maybe you were doing a brazing welding operation, there was a fastening operation. You're taking all of those things out. You're making it all one piece. There's inherent efficiency in the structure because now I kind of have parent metal the whole time. So people learn to deal with that because the risk is consonant with the reward, and or the reward is actually bigger than the risk. So they're happy to do that. And then the other one that I like is this, and there's any number of examples, it's this ability to print something which is difficult to analyze. And so there's good cases of people looking at things like thrusters. And so this is a very computational fluid dynamic problem. Okay. And so CFD works, but it's not easy to do. It's an expensive proposition. And really it comes down to understanding boundary conditions. You get any of those things wrong, the data is not going to be that meaningful to you. Very often, making that complex part was a problem but enter 3D printing, it knows how to make the complex part. So you'll have a situation where it's really easy now to make 12 versions of something. Each one has a unique change from the other, and just go do a flow test. And now you're getting empirical data versus relying on a complex analytical solution, which is really incumbent on the boundary conditions that you put into it. Wow. So, for us, when I was working in Australia, the example we had was the marine biologist came to us, and it's somebody's job to lure great white sharks up to the end of a boat, and then you jab it with a stick. The stick then has a little barb. The barb goes into the shark, and then they have these GPS trackers and salinity measurements, and so they can track the habits of these larger fish. But the barb that they were using didn't work that well, and it was titanium. They said, look, there's got to be a better way. Well, our engineers and scientists just came up with a dozen different designs. We printed them in one run overnight. And we just said, well, here you go. And they're like, okay, cool, we'll go try it. I'm like, okay, that worked out. And then they came back and they said, well, we like this. This one would be better if you did this. So we did one iteration and we were done. We came up with the new version of it. So again, there's no simulating the sort of the shark cartilage
No.
and the act of jabbing one with a stick. But that make and break philosophy, actually works.
Huh. Very interesting. Wow, that's cool. So do you guys, you said so you guys actually have some additive equipment like 3D printing, or do you outsource that, or?
We have partners for that. Yeah, we have.
Okay. And I guess any business can do that. I mean, I hear of these things like geometry and these types of things. What is your feel on that whole geometry business? Is it a good business where you can order this thing online and comes to you through the mail?
Yeah, I mean, what they're selling you is time.
Yeah,
it's not going to be necessarily cheap. This is not. Hopefully, our fine friends at Xometry don't take this as a cheap shot. No, they're selling you time and schedule because they have this network and they have capability, and so they can make that shape for you very, very quickly.
Yeah.
And sometimes they use additive and sometimes they use conventional means. It's kind of whatever they're making that decision for you, based on what you tell them. Yeah. So I absolutely think that there's, those are great businesses to be because, sometimes time's meaningful to you, sometimes it isn't. So I always tell people, like, when I was at Lockheed Martin, we making an F-22 like 1 month quicker may not have any value to anybody because, we've agreed to build 175. It's going to take however many years we said. So there's no like saving a month, and you rarely save up, and you think about that across all of the parts. All of the parts then have to show up, staged. So, it's one thing if you have a part of, a product that's in production, unless you pull all the parts in by a month, it's not helpful. But in order to get to that point, we had to make a couple of prototypes of the F-22, YF-22. And that's where, the Xometries of the world come in handy because now the cost of making an individual part might be inconsequential to having it for first flight.
Yeah. Wow. What an amazing airplane, by the way, or jet. Wow. I wanted to ask you, I'm glad you brought it up. Lockheed Martin. I always have been attracted to that company. I don't know. What's it like working there?
That was great. I was outside of, my business today, which I created with my team.
Yeah.
That was the thing I liked about Lockheed was it was a fantastic group of people who were dedicated to a mission, so we had a mission to, we make defense articles. That's what we do. And so for our allies, broadly, it was how do you help the warfighter? How do you help the allies do their thing? And so that sort of mission oriented space has always drawn me in. But I mean, talk about the caliber of engineers that work there is unreal.
It would be. Absolutely. Cool.
And
man.
it's really the environment that you work in too. And so I was at a meeting once, and we had a senior member from the government that came in, and he's like, I've been to this company, I've been to that company, why are you guys different? And head of Skunkworks said, well, we let people fail, because if you don't fail, you don't learn anything.
Absolutely right.
He's like, no, we do it. We make sure it's safe.
Oh yeah, you got to do that.
Yeah, we're not going to crash anything, but
No.
that always stuck with me. That was because you're, as a younger engineer, you're like, I don't want to mess up. I don't want to mess up. I don't want to mess up. But if you don't mess up, what are you really learning?
Well, and we all get indoctrinated to that from such a young age. I think that's changing now. But certainly it's like that no mistakes way of being brought up is, I don't know if it's good, but anyway, I hear what you're saying. So, I had another question and then it escaped me. Oh yes, I wanted to talk about collaboration and how important that is. I mean, you're talking about so many different things. You're talking about making products, you're talking about metallurgy, you're talking about going in and consulting, more or less, right? And helping these guys understand. And how important is collaboration to your business and all the way through the additive manufacturing industry?
Yeah, certainly it is important. And generally what I tell people and sometimes give talks on is the future really is a team sport. It's not becoming any more individualistic. Most of those days are really gone.
Yeah.
So if you look at all of the advanced manufacturing technologies, you talked about it, AI, you could talk about robotics, autonomous vehicles and autonomy, cyber, all of that stuff. It's not really a means to an end. It is only a component of something else. You don't have an AI factory. AI makes additive manufacturing better, or it makes the robot better, or it's mixed in with something to make that thing better. So what I always tell people, especially when I lecture at a university, is teams are your future. So being able to communicate in that team, and so it's tough for some. Not all. Personally, I'm an introvert. It's taken me a while to get to the point where I can go give a talk in front of a group. I've learned to cope with it by shutting myself in a dark room afterwards. But
I hear you, man. I'm the same.
You just need to figure out how to deal with it. But in general, that collaboration piece, it's the only way. It's there's just I think the days are gone of kind of that lone inventor toiling away at a bench someplace coming up with this new invention. I'm sure it still happens, but things are very complex now.
Oh, and I was just going to say, I think that's a sign of the times, is that it's so complex and we've moved so far that not one person could possibly do that on their own, right? So
yeah,
I agree.
There was a friend of mine once pointed out to me the DC-3, this is an iconic airplane, was made of entirely one metal and one aluminum alloy.
Wow.
And you think about today, a 787, it's 50% composite. It has probably half a dozen titanium alloys, probably half a dozen to a dozen aluminum alloys, has a couple steel alloys. It is a composite of composites. The thought that you could, from the DC-3 days, you could have a metallurgist because it's the same material.
Yeah.
Now you need a team of materials engineers to help you because all the processes are different, the materials are different. It's a much more complex thing.
It is. Absolutely. Well, what kind of advice would you give to anybody that loves the space, wants to get into it, that's, young? What's your advice to them, John?
Well, I think, do your research. It's always the same, go figure out what's out there, and think about what interests you about it. Is it the process technology? Is it the materials? I'm a materials engineer, so the materials piece was always really interesting to me. Designers tend to be very interested in additive because this ability to design new shapes is really exciting, that you would have a hard time getting to in a conventional or legacy manufacturing sense. And then if you're fortunate enough that you have the ability to go and get like a certificate in something, or kind of get that more formalized training or education in it, that's a decision people could make. But if you're like, that's a great symbol for a young person to show your potential employer that you're really interested, because you went off and showed some initiative and got some education, just like you would if there's a course that you could take in university. You always have electives. Why'd you take this one instead of that one? It shows interest. And and then just reaching out to other people that are in the space. Personally, having been involved in materials and aerospace for a long time, one of the things that appealed to me about additive manufacturing was you go to these conferences and it was just it was like a party. It was, because it was new and different. And on the one hand, they sort of liked what I had to say because I was coming in with experience in how to like make stuff. And if you grew up in additive, you knew about the additive technology, but you didn't necessarily know about manufacturing. And so, these two things kind of have to converge at some point. So I find that the additive community is a very fun crowd that's very accepting and very accommodating to all kinds of people, because it just wants to get bigger and better. So its interests are intertwined with bringing as many new people into it as possible.
Cool, man. I love it. Well, so for the young people, where can they find you? Or anybody. It doesn't just have to be young people. Anybody.
Right. Yeah, anybody. So we have barnesglobaladvisors.com.
Yeah.
That's our website. And we have some of our training and our we call our toolbox for people to kind of some graphics to kind of get their head wraps around. Mainly we do stuff at the corporate level. So with, direct to businesses. We do the Purdue University additive certificate. We're the instructors for that.
Okay.
So that's something that you can, it's 100% online. You move at your own pace. So people can go go get their certificate in additive. But other than that, do the speaking circuit, at a conference near you. But certainly LinkedIn, it's another area, of course, where we got introduced.
Yeah, absolutely, man. Well, and I'll put all that in the description. Thank you very much for your time. It's appreciated.
Yeah, thanks a lot. I'm glad that we connected.
Yeah, man, me too. We'll keep talking.
All right.
Okay, John. Thank you.
Thanks.
We'll talk to you soon.
Okay.
Greg Sheldon here, your host of Metal, Steel, Manufacturing, and Business Pro podcast, where you learn everything about the metals and manufacturing industry that make your modern day life possible.